Hi friends, good evening. Can you hear me properly? Can you please comment? Okay, thank you. So today we are going to discuss some important questions that is commonly encountered with the competitive examination from Fourier and Laplace transform, right? Based on the exam which we conducted today, right? So the first question is, the first term of the Fourier series of f of x, pi minus x whole square by 4 in the range minus pi less than x less than pi. So, what is the first term of Fourier series expansion? It is a0 by 2, right? So, any function which we can represent as a0 by 2, right? a0 by 2 plus sigma n is equal to 1 to infinity an cos n x plus sigma n is equal to 1 to infinity bn sin n x, right? All right. So what is the first term? A0 by 2. So we need to find A0 by 2 as per the question, right? What is A0? A0 we have defined as 1 by pi integral minus pi to pi f of x dx, right? So what is A0? That is 1 by pi integral minus pi to pi. The function is given, that is pi minus x the whole square divided by 4, right? So let us integrate this. We can take this 1 by 4 pi out, right? And when we integrate this, I can write as pi minus x whole cube divided by 3, right? And then we can see we can divide with its differential, that is minus 1. So we have a negative outside. So limit is minus pi to pi, right? So that is equal to minus 1 by 4 pi. So let me substitute the limit, right? So we can erase this. Okay, that is minus 1 by 4 pi. So when I am substituting pi, this part will be 0. When I am substituting minus pi, so this will be 2 pi whole cube, right? When I am substituting pi, the answer will be 0 minus here 2 pi whole cube divided by 3. All right. So that is equal to, so this negative and negative become positive. So 1 by 4 pi into 8 pi cube divided by 3. So that is equal to 2 pi square divided by 3. So we need to find first term. This is a0 value, right? What is the first term? A0 by 2. So 2 pi square by 3 divided by 3. So divided by 2, right? So this 2 and 2 cancel. So pi square by 3 is the answer. So which one is the option? Option B is correct, right? All right. Now another question is, consider the following triangular periodic wave function, periodic wave of period capital T, and a graph is given, that is period T, a triangular wave is given. The first term of the Fourier series of this triangular periodic wave is. So we need to find the first term. What is first term? Again, first term is a0 by 2. So we have to solve it from this graph, right? All right. So how can we represent it periodically, right? Using Fourier series expansion, how can you find a0, right? So we already know the general expression for this Fourier series a0 is equal to 1 by pi integral minus pi to pi f of x dx, right? So instead of this pi, so there we have considered a sine wave with pi. Pi is corresponds to here t by 2, right? So let me write the pi, we can replace with t by 2. So 1 by t by 2. So here this minus t by 2 to t by 2 and f of x, right? What is f of x value? F of x, that I can write f of x dx, right? So here the x-axis is the function of time. So let me write this as f of t dt, right? All right. Now the function is defined in the interval 0 to t, right? 0 to t. So one triangular wave is defined 0 to t. So this width t by 2 minus t by 2, that is equivalent to this. So it has only the positive values. So we can simply write this as integral 0 to t, right? The limit is 0 to t. So we can replace this with a0. This I can write as 2 by t. So this limit I can changes into 0 to t, right? Instead of taking t by 2 to minus t by 2 to t by 2, right? F of t dt. Now what is f of t dt? If you have a given a graph, suppose this is my y is equal to f of t. So this integral f of t dt, that representing the area of this graph, right? So what is the area? Area is equal to, otherwise you have to do integral 0 to t by 2 and t by 2 to t, and you have to define this function, right? So we can use the symbol technique. Any function integral f of t dt, that is representing the area of the graph, right? So 2 by t into, what is the area? This is a triangle with area half into base is t and height is given in the question, that is a, right? So what will be the 2 cancel, t cancel, so a0 is equal to a, right? We need to find the first term. First term is a0 by 2. A0 is a, and so a by 2. So what will be the answer? First term of the Fourier series is a by 2. All right. All right. So which one is the option? Option is B. All right. All right. Now we have another question here. The Fourier series of a periodic function with the period 2 pi is given by f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. If f of x is defined by f of x is, that is x in the interval minus pi by 2 to pi by 2, and pi minus x if pi by 2 less than x less than 3 pi by 2, right? So to do this we have to find out the integral, right? So we need to find the a0 value, right? So we for this particular function, what is the value of a0? So we can compare with our ordinary Fourier series expression. So a0 is 1 by pi integral minus pi to pi f of x dx, right? But here the problem is this minus pi to this pi corresponding to, what is this pi? Pi is that is equal to, see, look into here. Suppose you are considering minus pi to pi, that is the width, right? What we are going to write here? So that is the width, half of the width of this, right? What is the half of the width of this interval, right? So that is equal to, here the function is 1 by, so here the width is pi minus pi, that is 2 pi. 2 pi half is pi. So here we have to write the width of this, right? What is the width? Here the interval is varying from minus pi by 2 to 3 pi by 2. So what is the difference, right? Minus pi by 2, 3 pi by 2, that is 3 pi by 2 minus pi by 2, right? That is the width, right? And you have to divide it with 2, all right? So that is what is corresponding to pi, all right? Integral, and this interval is minus pi by 2 to 3 pi by 2 f of x dx. Now let us do this 2, we can take to up, right? So 2 to 4 minus 2 pi, right? 4 is here, and here 3 pi plus pi 4 pi, right? Okay, so 4 divided by 4 pi. So 4 cancel, and this interval, in this interval we can split this into minus pi by 2 to pi by 2. The function is x dx plus integral there pi minus x, right? Pi by 2 to minus 3 pi by 2, not minus 3 pi by 2, 3 pi by 2. Their function is pi minus x dx. That is pi minus x dx. Now we can integrate, right? Then substitute. Okay, so when I integrate, a0 is equal to 1 by pi into, so this is x square by 2, limit is minus pi by 2 to pi by 2, plus this part will be pi x minus x square by 2, limit is pi by 2 to 3 pi by 2, right? So I have integrated this part. Now when I am giving this part will be 0, right? So pi by 2 whole square, so this will be positive, and minus pi by 2, so this term is 0. So here if I give pi into 3 pi by 2 minus 3 pi by 2 the whole square, so 9 pi square by 8, alright? That is upper limit minus lower limit, that is again pi square by 2 minus pi square by 8, alright? So this will be the final answer that we are expecting. So that is 3 pi square by 2, that I can write as 3 pi square by 2 into 4 we can write, right? So that is 12 pi square by 8, right? Multiply numerator and denominator with 4. 12 pi square by 8 minus 9 pi square by 8, minus here also I can write 4 pi square by 8 minus pi square by 8. So 12 minus 9, so this will be 3 pi square by 8 minus here also 3 pi square by 8. So answer is 0, right? So a0 value is 0. So which one is the option? Option A is correct, right? Now let us go to another question. The Fourier series of the function f of t minus 1 in the interval minus pi omega less than t less than 0, and it is plus 1 0 less than t less than pi by omega in the interval minus pi by omega less than t less than pi by omega, right? So can be written as, so obviously we know this function has odd nature, right? In the negative interval it has negative value, in the positive interval it has positive value, right? So it is an odd function, so we can write a0 an, these values are 0. So to expand in Fourier series we need to calculate only this bn value, right? So what is bn? Bn is equal to, that is defined as 1 by, so here the interval is pi by omega, right? So in the interval pi by omega minus pi by omega to pi by omega f of x dx, right? What is f of x, right? F of x is that we can split into two interval. So bn is equal to omega by pi into, all right, omega by pi into integral minus pi by omega to 0. So we can split into two interval. There the function is minus 1 dx. So it is bn, right? So an is, so sin n x dx we have, all right? So that is minus 1 sin n x dx plus omega by pi into 0 to pi by omega. There the function is plus 1. So 1 into sin n x dx, all right? So when I am integrating omega by pi, what is the value of sin nx on integrating? Minus cos nx by n. So this will be cos nx by n minus pi by omega to 0 plus omega by pi into, here also this is minus cos nx by n. So that minus I can keep here. Okay. Limit is 0 to pi by omega. Alright. Alright. Now, let me write this as, so I can erase for the time being this. Okay. So when I am using this pi by omega interval, so I can write this as n omega t. So variable is n omega t, right? So n omega t in terms of omega, and the function is represented as Fourier series representation is n omega t, right? All right. So what we can write about this? Okay. So here also by the integration we have 1 n omega here. Here we have n omega. So this omega and this omega will cancel. This omega and this omega will cancel. Now let us substitute the limit. Then 1 by pi. That is here this cos 0 n. So I can take this pi n out. And here what will be the result? This is 1 minus pi by omega. If I replace with this sin cos n pi, that is minus 1 raised to n, minus, if I replace here pi by omega, right, omega cancel, and again we can take this pi n out. What is remaining here? Here also minus 1 raised to n, minus again cos 0, that is 1, right? So we can write this as 1 by, so let me take pi n out. So 1 minus minus 1. So here we have 2, right? Here we have 2 times, here minus 1 raised to n, here minus. So 2 times minus 1 raised to n. Alright. So this is equal to 2 by pi n into 1 minus 1 raised to n. So this will be the result. Alright. Now let me substitute this value. This is my Bn. So here the thing is, this is my Bn, and from it is clear that this Bn will exist for only for odd values, because if I substitute even values, suppose you substitute n is equal to 2, so minus 1 square, that is 1, 1 minus 1, 0. So it is exist only for odd value. So Bn value is equal to, I can write for n is equal to odd, this become 4 by, right, 4 by n pi, right? So 4 by n pi. So when it is odd, this become 2, and here become 4 by n pi for n is odd. All other term is 0. Even values are 0. Bn is equal to 0 for n is even. Now we can substitute these values in series expansion. That is what is our question, right? So what is the question? Represent this series, right? We have to represent the series. That is sigma, that is f of t is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos n omega t plus sigma n is equal to 1 to infinity bn sin n omega t. Now this term is 0, this term is 0 because it is odd function a0 and n is 0. Here only we have the term sigma n is equal to 1 to infinity bn is equal to 4 by n pi cos n omega t. This term only we require, and n is odd, right? Even we need not. So we can give only odd values 135, right? So all even condition, the answer will be bn value is 0. So this is the um, this way we can represent, right? So which one is the option? So 4 by pi we can take out. What is remaining? So odd values only require. So this is the result, right? 4 by n pi, I'm sorry, sin n omega t, right? So this is sin n omega t. So sin n omega t. All right. So option D is correct, right? All right. Now let us go to another question. Laplace of d square y by dx square is Laplace of nth derivative, right? Y raised to n. That is we have studied as y raised to n means nth derivative, right? That is equal to s raised to n minus 1. We have studied s raised to n minus 1 Laplace of y minus s raised to n minus 2, right? y0 and minus s raised to n minus 3 y dash 0 and minus s raised to n minus 4 y double dash 0. The series is going like this, right? So Laplace of y2 we require, right? Laplace of y2 second derivative. So that is equal to, so let me use another color. That is equal to s raised to second derivative, n is equal to 2, right? N is equal to 2. So which one will be the option? The option is s raised to the second derivative, right? So it is s raised to n Laplace of y. I'm sorry, it is s raised to n Laplace of y, s raised to n minus 1 y of 0 and s raised to n minus 2 y dash of 0. The series is going like this, right? All right. So s raised to n Laplace of y means that is s square Laplace of y. And next term is n is equal to 2 means, so this is s raised to 2 minus 1. So s Laplace of s y of 0 minus next term is 0, s raised to 2 minus 2, s term is end here. So we have only term y dash 0, right? So this will be the expression. So which one is the option? S square Laplace of y minus sy0 minus y dash 0. So this one is the option. All right. So option A is correct. All right. Now we have another question here. Laplace inverse of s by s plus 2 whole square plus 4. So let me write this as a Laplace inverse of s divided by, here this denominator s is added with 2, right? So we have to make the similar term here, s plus 2 minus 2. I have added 1 2 with the numerator and subtracted it. So this I can write as Laplace inverse of s plus 2 divided by s plus 2 whole square plus 4 minus Laplace inverse of, so let me write it down, right? So this is equal to, I can split this into 2, s plus 2 divided by Laplace inverse of s plus 2 divided by s plus 2 whole square plus 4 minus Laplace inverse of 2 divided by s plus 2 whole square plus 4, right? Now we have two standard result. We have studied Laplace inverse of s divided by s square plus a square. That is what? That is equal to cos omega t. And Laplace inverse of a divided by s square plus a square, that also we have studied. That is sin omega t, right? So when you look into this, here s is replaced with s plus 2, right? So we already know the result is here cos into, what is this is cos omega t, not cos omega t. Here constant is cos at and this is sin at, right? So what is A? A is this 2, right? 2 square. So from this it is 2 square. So this is cos 2t. But we have to, this s is added to with a 2. So when s is added with some term, you have to multiply with e raised to negative of this. That is minus 2t. Alright. And here also a by s square plus a square format. So sin at is the result, that is sin 2t. But here s is added with 1 2, right? So you have to subtract. You have to multiply with the exponential term with the negative of this added term, that is minus 2t. So you can take this e raised to minus 2t out. What is remaining? Cos 2t minus sin 2t. So which one is the option? Option D is correct, right? Option D is correct. Alright? Alright. Now we have another question here. Solution of the differential equation dy by dx plus 2y equal to 1 with the initial condition y of 0 is equal to 0 is. So to solve a differential equation using Laplace technique, you have to apply Laplace on either side of the differential equation. So Laplace of dy by dx plus 2y, that is equal to Laplace of 1, right? Alright. So what is Laplace of dy by dx? Laplace of dy by dx is plus 2 into Laplace of y equal to Laplace of 1 is 1 by s, that we have studied. What is Laplace of dy by dx, right? Laplace of dy by dx is s into Laplace of y, s raised to n minus s raised to n Laplace of y. What is s raised to n? So s Laplace of y minus y0, right? So this is the Laplace expansion of dy by dx plus 2 into Laplace of y, that is equal to 1 by s, and this y of 0, that is 0 is given. So y of 0, this I can give as 0. The only term is remaining this. Here I can write Laplace of y, that is equal to Laplace of y, if I take out s plus 1, is equal to 1 by s, right? So this I can write as Laplace of y is equal to 1 by s into s plus 1, right? So this I can simply write as 1 by s minus 1 by s plus 1, right? S plus 1 minus s, right? So again write, what is y? Y is this Laplace inverse of 1 by s minus 1 by s plus 1. So what is y? So we need to find y value. That is 1 by s is Laplace of 1 by s is 1 minus, and what is 1 by s plus 1? 1 by s plus 1 is e raised to minus t, right? E raised to minus t. Alright. So which one is the option we have? So here we missed a term, right? 2y, right? So here we have a 2, right? I'm sorry, here we have a 2. So let me check. Okay, so we have a 2 here. We have missed this 2, right? So we can write this as Laplace of y equal to 1 by s into s plus 2. I'm sorry. So here we have a 2. So this we can write as 1 by 2 into 1 by s minus 1 by s plus 2. So s plus 2 minus s, that is 2 by s into s plus 2, 2 to cancel. So we can write like this, right? So we have a 1 by 2 out. We have a 1 by 2 out. right? So this part will be s plus 2. So this will be, so this Laplace transform function is in the form of x. So the variable is we have to write e raised to minus 2x, right? So this will be the result, right? So y is equal to 1 by 2 into 1 minus e raised to 2x. So which one is the option? Option A is correct, right? This we can simply do. You need not do in the way of Laplace transform. We have already studied in differential equation. You can find out integrating factor. This equation is in the form of dy by dx plus p of x y is equal to q of x. Then what is integrating factor? E raised to integral p of x dx, that is equal to e raised to integral, what is p of x? That is 2 dx, that is e raised to 2x. Then what is solution? Y into if is equal to integral if into q of x dx. This method we have already discussed. So y into e raised to 2x is equal to, what is if? E raised to 2x into, what is q of x? That is 1, right? 1 dx. So y into e raised to 2x is equal to, this one integration e raised to 2x by 2 plus c, and it is given that y of 0, right? So when you put x is equal to 0, you will get y is equal to 0. So this term will be 0, this term will be 1 by 2 plus c. So c is equal to minus 1 by 2. That you can substitute here. So y e raised to 2x equal to e raised to 2x by 2. C is minus 1 by 2. So I have substituted the value here. Now we can simplify. You can apply either this Laplace technique or this integrating factor technique. So this 2x is dividing here. So this cancel 1 by 2 here. We have to multiply with e raised to minus 2x. So this is nothing but 1 minus e raised to minus 2x divided by 2, right? Or 1 by 2 into this. So the same result we got, right? Alright. So Laplace technique also we got the same result. Now we have another question here. Laplace inverse of 1 by s cube, that is 1 by s cube is equal to, we already n factorial divided by s raised to n plus 1. This I can rewrite as so this will be equal to this I can write as 1 by 2 factorial into 2 factorial divided by s raised to 2 plus 1. I am replacing into the standard form. Laplace inverse of, here 1 factorial divided by s raised to 1 plus 1, and here Laplace, these all are in the standard form, right? So this I can write as 1 by 2 into, this is 2 factorial divided n factorial divided by s raised to n plus 1, that is t raised to n, that is t square, plus here 1 factorial divided by s raised to, so this is t raised to 1, plus 1 by s Laplace inverse is 1. So half t square plus t plus 1. So which one is the option? Option D is correct, right? Alright. Now let us go to another question. Fourier transform of which of the following function does not exist, right? So to exist a Fourier transform, the condition is at x is equal to plus or minus infinity, the function should be finite. F of x should be finite, right? So if you give plus infinity or minus infinity here, due to this outside negative sign, this function is finite, right? Here also due to e raised to minus exponent term, so when you substitute x is equal to infinity or minus infinity, this part will be finite, so entire part will be finite, right? Alright, and this also the same, but here the problem, here due to this e raised to plus infinity whole square, that is going to be infinite quantity. This term is going to infinite. So option C is correct, right? Alright, and also the x is equal to 0, right? At x is equal to 0 and x is equal to plus or minus infinity. this whole condition, the function should be finite, right? All right. Now we have another question here. Find the Laplace transform of f of x at 1 plus x e raised to minus x whole cube, right? So we can expand this first to make it in the standard form, right? F of x is equal to 1 plus x e raised to minus x whole cube. So that is f of x is equal to, so let me write it down. F of x is equal to a cube plus 3a square b, right? 3 a square b x e raised to minus x plus 3b square a, right? That is the 3 into x square e raised to minus 2x plus b cube, that is x cube e raised to minus 3x. So this will be the term, right? So Laplace, find the Laplace transform of this. So Laplace of f of x equal to 1 plus 3 into Laplace of x e raised to minus x plus 3 into Laplace of x square e raised to minus 2x plus Laplace of x cube e raised to minus 3x. So this will be the terms, right? Now we have already studied a result. Laplace of x raised to n e raised to minus, so not f of t. We have studied a standard result for this, minus 1 raised to n d raised to n ds raised to n f of s. What is f of s? F of s is the Laplace transform of this f of t, right? So using this we can find out this result, right? So what is Laplace of 1? Laplace of 1 is we know that is 1 by s. So we are focusing on the remaining term 3 into, so here x raised to 1 e raised to minus x, x raised to 1 e raised to minus x. So n is equal to 1 here, f of t is e raised to minus x, right? So what I can say, minus 1 raised to 1. So there is a minus sign, right? All right. So x minus 1 raised to n. So n is equal to 1 here. All right. So what I can say, that is minus 1 raised to 1. So that is equal to minus 3 I have put out, right? And this f of t is equal to what? E raised to minus x. What is the Laplace of f of s? Is the Laplace of this f of t. What is the Laplace of e raised to minus x? That is 1 by s plus 1, right? 1 by s plus 1. So we have a derivative here, first derivative of 1 by s plus 1. Now that is 3 into Laplace of x square e raised to minus 2x. So it is x square, so minus 1 square here, and we have double derivative, d square divided by ds square. What is my f of s? F of s is equal to differential, that is the Laplace transform of this e raised to minus 2x, that is 1 by s plus 2, right? And plus again this here x cube, so minus 1 whole cube into here d cube divided by ds cube, right? Into Laplace of e raised to minus 3x, that is 1 by s plus 3. Now the step is over. Now we need to differentiate only. So let me erase this all. So this will be 1 by s plus, so this here we have a minus, but this will be minus 1 by s plus 1 whole square, right? 1 by s plus 1 on differentiation, minus 1 by s plus 1 the whole square. So that minus and this minus will cancel. So 3 by s plus 1 the whole square. Next term is, we have a 3 here, and this minus 1 square is plus, and double derivative, first derivative of this is minus 1 by s plus 2 whole square. Again differentiation, we have minus 2 by s plus 2 whole cube. That is negative and negative cancel. So we will have 2 by s plus 2 the whole cube, right? So 6 by s plus 2 the whole cube. Next term is, we have a minus 1 minus here, and we have 3 differentiation here. First differentiation, 1 by s plus 3 on differentiation, 1 by minus 1 by s plus 3 the whole square. This is again differentiation gives, that is minus plus 2 divided by s plus 3 whole cube, and again differentiation gives, that is minus 6 divided by, right, minus 6 divided by s plus 3 whole raised to 4. So we can substitute here minus 6 divided by, so we have already a minus here, so minus 6 divided, that is minus 1 cube, s plus 3 the whole raised to 4. So which one is the option? 1 by s plus 6 divided by s plus 3 whole raised to 4. We can, that is 3 divided by s plus 1 the whole square, and 6 divided by, again 6 divided by s plus 2 the whole cube. So which one is the option? Option A is correct, right? All the terms are involved here, right? 1 by s, 6 by s plus 3 whole raised to 4, 3 by s plus 1 whole square, 6 by s plus 2 the whole cube. So option A is correct. Alright? Alright. So this is all about this exam paper discussion, and in the next section, next class, we will start with electrodynamics, magnetostatic, that is part 2. Okay, thank you.
CEED Physics Clinic is a unique career endeavor, provides organized coaching for UGC-CSIR NET and IIT JAM. We provides live interactive classes, online exam series, and organized study materials. For more details, contact 9388877666.